Hi, I'm Christopher Collins. Today I'll be presenting COVID Connect, our chat-driven anonymous story sharing system for peer support, a collaboration between Ontario Tech University, Ontario Shores Centre for Mental Health Sciences, and the City of Oshawa. I'm joined today by my co-authors, Nathan and Zushin, to help with the presentation on behalf of our other collaborators, Simone, Sean, and Jennifer. In addition to illness and death, COVID-19 brought immediate and drastic changes to our lives. From empty classrooms, closed playgrounds, and product hoarding, to days of boredom, warnings, and Zoom birthday parties, the direct and indirect effects of the pandemic were numerous. It's within this context that we decided to create COVID Connect. In fact, some of the pictures you see here are from our own lives. So as we were also living through the pandemic, we were inspired to take an autobiographical design approach, acting as both designers and the representatives of the target audience. Our aim was to create something quickly and continuously improve it through iterative development in order to address this pressing need.
At the height of the pandemic, accessing mental health support was limited. Moreover, many people could not afford, did not have the time, or were not comfortable talking to another person about their problems. So we were inspired by other similar, low-cost, and automated approach to providing support. Therapist chatbots like Eliza, created by Joseph Weizenbaum in the 1960s, saw that simple chat scripts were sufficient to engage and encourage people to share personal stories. Together All was another source of inspiration for our project. They provided a combination of one-on-one help and peer mental support help. Another source of inspiration is a community art initiative called Post Secret. They invited participants to mail postcards to curators of the site where they would be displayed. Because people were allowed to be anonymous, they shared personal and thought-provoking stories. We wanted our system to be free and accessible across multiple platforms. And since mental health is a private subject, we anonymized the messages and allowed users to request to delete their messages from our database. Due to the gravity of the pandemic, we deployed our system as quickly as we could and used iterative refinement. To understand what our target stakeholders' concerns were, we conducted a survey and gathered a focus group of HR professionals at our local municipal government. The survey and focus group revealed that the most common themes reported by participants were related to school, working from home, loneliness, and more. With these themes, we hope to create an inviting and engaging chat script informed by professionals within the mental health sector. We were advised to use open-ended questions, acknowledge and affirm, demonstrate patience, and on a positive note, and invite further participation. The chat agent attempts to detect the intent of the user's messages and generate appropriate responses to 3 sentiment categories and 10 of the previously mentioned topics. When the agent can't detect what the user's intent is, it chooses one of the 9 redirect responses provided to us by our mental health professional team members. For example, what is the best thing that happened to you over the pandemic?
We underwent several rounds of sketch-based brainstorming with the full lab to refine the user interface and layout, with the aim of integrating the chat area with some type of visualization of previous statements. The final design centered around the idea of bubbles containing the full text of previously submitted stories and a central chat window for dialogue with the agent. Due to the stressful nature of the context in which the project was deployed, we decided to use a more cheerful color scheme. We based this idea on a metaphor of bubbles, which are temporary, colorful, and move in unique patterns. The final design removed the border between the chat window and the bubbles to integrate it as a single application. The chat window relates to a zoomable canvas, which is continuously populated with bubbles, which show previously submitted stories related to the current chat. We intentionally do not use summarization or aggregation visualizations, instead showing the full text in order to honor the individual stories that were submitted.
Numerous features were implemented in the interest of maintaining user privacy, such as toxic comment screening, detecting distress in chat and redirecting to emergency services, detecting and anonymizing named entities, and allowing users to delete their data at any time with a unique code. In addition, there's a 3-day data holdback for user data. The application starts with a welcome screen that describes the purpose of COVID Connect. When the user decides they want to chat, they're taken to a consent form, and they must scroll to the bottom and pass a CAPTCHA to proceed. Once inside the application, the participant may begin to send messages immediately. After the participant sends their first message, we use natural language processing techniques to search the database for similar texts, then render those texts as bubbles on a zoomable canvas in the background. Bubbles can be selected to zoom in and provide upvotes or feedback. At the end of the chat session, the agent provides a link to a feedback survey. COVID Connect is free to use and was created with open source libraries. All data is stored on our private servers and the chat AI is locally hosted. Due to the urgent nature of this research, we had a fast launch and used iterative refinement through observing logs to fix any bugs and improve the system. Here we have the complete system diagram, which comprises of 3 logical groupings: front end, web and data backend, and natural language processing, which each have discrete components. Communication between components is denoted by edges, which are also color-coded to denote the class of data being communicated. The front end consists of the chat bubble visualization, the chat box, and user and data management functions. The chat box communicates directly with the RASA agent to enable a rich conversation experience. In turn, the agent triggers chat bubble visualization updates, ensuring the contents of the most recent bubbles is similar to the topic the user is currently discussing. Natural language processing is primarily composed of customized RASA open source components. The RASA agent implements the NLU pipeline and dialogue policies. At the highest level, chat messages from the user enter the NLP system, and it in turn replies with the agent's response to the chat box and sends event messages with parsed data to the message broker, which are acted upon by the web and data backend. The web and data backend is responsible for the system logic and control. It ties together the disparate components via the message broker, interacts with the database, scrubs messages of personally identifying information and archives them, performs message similarity searches, and also implements user data controls.
We launched COVID Connect in March 2021, and while it remains online, our data snapshot was taken in February 2022. Recruitment was carried out by direct emails to employees and students at partner institutions. We also posted on social media and used posters. This project was also featured on News Story, and additionally, we invited people to forward the recruitment to their networks. For our data collection, we had a total of 409 unique sender IDs. There are over 1,700 user messages. Most of the messages we obtained consisted of greetings and simple yes or no responses. So to conduct qualitative analysis using open coding, we filtered the messages and only analyzed those with more than 5 words. The analysis was conducted using a 2-path method, involving a researcher going over all the entries manually and then consulting a mental health expert co-author to discuss the data groupings and overarching themes. Since our system was created to act as a story sharing platform, we found that many messages started with the pronoun I. To understand any patterns, we created word trees with the messages started with I, and here you can see those that start with the phrases I miss, showing that people miss going to places, seeing their families, friends, and loved ones. Similarly, looking at the word tree created using the messages started with I have, we can see that people want to share their thoughts with our agent, telling them that they weren't feeling the best or had no one to talk to. They also told it very general status reports like I have a runny nose or I have an appointment today. From these messages, we can see that participants were able to have meaningful conversations with the agent despite just having a simple chat script. Through axial coding, we detected 11 high-level categories with some messages belonging to 2 categories. The higher-level categories were further clustered into 3 themes: emotion, experience, and bonding. The larger category of emotion-based messages were derived using Dr. Laura Wilcox's feeling or emotion wheel. The main emotion expressed in the data we collected were hopeful, sad, angry, and bad. Some expressed frustration with their life, work, and restrictions, and so on. The other theme expressed in our data were people talking about experiences or topics. For example, the melding of personal life with work life affected people's relationship with those that they live with. We found that people generally interacted with our agent as if it was a confidant or a friend. There were messages asking for help, expressing personal emotion, having a small talk. Overall, the types of information that people shared with COVID Connect were surprisingly heartfelt, emotional, and relatable to our own experiences during the pandemic. An alternative framing of our analysis was to examine the data from the perspective of challenges and coping mechanisms. Many poignant stories of the pandemic challenges were submitted. For example, because I'm far from home, I feel like everyone back there is getting on with their lives and I'm stuck waiting for life to start. The challenges were met by creative and diverse coping strategies. For example, one user wrote, "I've connected with my neighbors a bit more because we're all at home so much. We see each other around a lot."
In addition to analyzing the data collected, we also reflected on the design process and outcomes of the deployment. We found that the simple chat script was effective in engaging people, even though the chat agent had a relatively limited vocabulary of statements. The use of open-ended statements was surprisingly effective at eliciting detailed and moving personal stories, sometimes even from ourselves as participants. However, we did notice that chat logic failures may have discouraged continued use of the system as people provided this feedback directly to the chat agent. As the use of our external feedback survey was not well used, we recommend in future that feedback mechanisms be integrated directly with the chat system itself. We do see opportunities for the use of such a tool in additional scenarios, for example, anonymous peer support story sharing systems for addictions recovery. We have presented COVID Connect, which remains online and available for you to use to share your pandemic stories and read the experiences of others at covidconnect.me.